Right. So you have understood now elasticity. So elasticity is the property of the body. So it is the property of the body, any type of body, whether it is human body or whether it is steel, it is metal, it is non-metal, anything. It is the property of the body. So each and every body is somewhat elastic. Somewhat elastic. We cannot say that completely elastic, somewhat elastic, each and every body. It is the property of the body due to which it regains its original position when the load is removed. If any load is there, then some deformation will be taking place. That is called deformation. Okay, some changes, either change in length will be there, or change in, you can say, its area will be there, change in volume will be there, any change will be there. Right. Now, so when that load is removed, that change will be coming back to its original position. Right? That is called elasticity, and body can be said as elastic. Example, rubber, steel, wood, anything it is there, somewhat elastic everything. Another property is there, that is called plasticity, and if the body is loaded, okay, so now when this plastic stage will come only when elastic limit has crossed. When the body's elastic limit has crossed. Okay, suppose if a body can sustain 5 kg load, within 5 kg load the body will be regaining back its original position when that load is removed. But if I have put some 6 kg load, if the body is loaded with 6 kg, okay, so what we want to say, that suppose the elastic limit for this particular body is up to 5 kg load, right? 5 kg load, up to 5 kg load, there will not be any problem on this body. Okay, even if some little deformation is taking place, its area and everything will regain back its original position. But the moment you have applied 5.1 kg, then some more deformation will start occurring. Deformation means what? Deformation means its change in length, change in area, change in volume, that is there. Huh? Okay, so 5.1 kg, 6 kg. So the moment we are putting any 6 kg load, after that this body will have some deformation, permanent deformation. When the permanent deformation starts, means it has already crossed its elastic limit. The load has already crossed its elastic limit and permanent deformation has started. Permanent means that deformation will not be regained back. It will be somehow, you can say, it will change its area. Some load will be compressing it. Sometimes change in length will be there. Okay. If this side it is increasing, change in length will be there, change in breadth will be there, that will be permanent. Then you can say that the body. And after that what will happen when the load is removed, 6 kg load is removed, that deformation will be completely permanent. Completely permanent. Correct? Then the body will be said as plastic. Then the body will be said as plastic. Okay, so each and every body up to certain extent, up to certain load, it is elastic. Right? Understood now elastic and plastic? Very good. So now we will be studying about stress and strain. Stress. Stress is what? Load per unit area. Load per unit area of the body, or load applied. Better we will be writing load applied per unit area of the body is called stress. Is called stress. So load applied per unit area of the body is called stress. Okay. Now this stress, suppose it is denoted by S, then it will be equal to, so load. Load is force. Weight is also a force. Okay, so that load is having some weight, so that's why we are writing force per unit area. Per unit area. Right? Okay, so now understand that what actually is the stress. Stress is the property, internal property of the body due to which it resists any type of load. Suppose we apply a load on this particular body by applying a weight of some 5 kg meter per second square or Newton, 5 Newton. Force is there. So 5 Newton we have applied the force or load on this body. Now internally this body will resist this load. The body structure, molecules, it will be resisting this particular load. Understanding what is stress? So stress is the internal property of the body, its own inherent property of the body by which it is resisting the load. It will create a resistive force. That is called stress. So stress is the body's internal resistive force. Right? Okay, so we can also write it as stress is an internal property of the body by virtue of which it resists the externally applied load. Understood now? That it is body's internal resistance force due to which it is resisting the externally applied load. Understood? And it is calculated by force per unit area. So force is nothing but load applied. Okay, where F is equal to load applied and A is area of the body. Understood now? Right. Now another particular topic is there here. Okay, one more thing I will be telling you, and that is types of stress. Types of stress. So first one, tensile stress. Tensile stress. Okay. Second one, compressive stress. And third one, shearing stress. Shearing stress. Tensile stress is what? Suppose if a body is there and it is pulled from its side. It is pulled from both the sides. Okay, here also one force is applied, here also one force is applied in opposite direction. The body is pulled. So in that case, what will be happening? So its area will get reduced, its length will increase. Correct or not? Here what we are doing, we are pulling the body from both sides in opposite direction. So its area will get reduced, its length will increase. Correct or not? So this type of stress is called tensile stress, in which tension is there, tension. Okay, just like a strain. So this is called tensile strain, tensile stress. Okay. Now another one, compressive stress is there. So in this tensile stress, area reduces, length increases. Yes or no? Increases. In compressive stress, suppose a particular body is there, and in that particular body you are applying some load F1 and F2 in this way. Like suppose this particular body I am having, and this particular body I am compressing it from both the sides. So what will happen? Its length will get reduced, its area will increase. Correct or not? So in this case, when you are compressing it, so this particular portion will be increasing. So this is called compressive stress. Correct? So its total length will get reduced, but in this portion it will be increasing. Right? Okay, so this is called compressive stress. Shearing stress. Now shearing stress is what? It is at an angle. So here I will tell you. Right. Now suppose this particular body ABCD is placed on ground and this particular BC is fixed. Particular BC portion is fixed, welded. Okay, so this one you can say fixed surface on ground. Understood now? Like suppose I have kept my leg on ground firmly, and if you pull my hand, so leg will not be moving. So if you will be pulling my hand, then what will happen? I will be moving like this, but my leg is not able to move. So at an angle my movement will be there. Okay, so then what type of stress will be created? Angular stress will be there. That is called shearing stress. Okay, so in this case, suppose if I am applying any load at this particular position F and I am pulling it, so this surface will try to move that side. Okay, so what will happen? This surface has moved. So new position has become what? B and PQ. So this particular surface has shifted itself at an angle of theta. Correct or not? Because this particular surface was fixed. Then this type of stress, especially, it will be called as shearing stress. Okay, where angular displacement takes place. In system of particles and rotational motion, already we studied about angular displacement theta. So here angular displacement takes place. Correct? Okay. So this will create angular displacement. Understood now? So what are the different types of stresses are there? Tensile stress, what it will be doing when you are pulling the body from both sides. Okay, pulling the body. Then compressive stress when you are compressing it, pressing it. Shearing stress when angular displacement will be taking place. Right? Okay, so just please note it down. Then we will go for strain. So very important concept is there, that is stress. In this mechanical property of solids, stress and strain is playing a major role here. Right? Whether you have noted down this one, top side? Okay. Figure also noted down. And then will be our next topic is strain. So very important property. Right. So next topic will be strain. So stress is mainly an internal property of the body. Generally what we are saying is stress is the external load. So it is not the external load, gentlemen. It will be the internal property. It is a resistive property by which a resistance will be created for that external force. Okay? Right. Okay, can we go to strain?
For what will happen for compressive stress?
Compressive stress. Okay, so what it will be there? You can say its width will be increasing. Its width will be increasing. So you can say width increases and length decreases. In this case, what you can say, not area, so what you can say, width decreases. Right? In tensile stress, width decreases, length increases. In this case, width will increase, whereas length will get reduced. Okay. And in shearing stress, there will be an angular displacement will be taking place. Okay. Right. So now strain. So strain, how we are defining? We are defining that strain as deformation per unit length. Deformation per unit length is called strain. Now question arises that this deformation is what? So deformation can be change in length, can be change in area, can be change in volume. Right? So this deformation per unit length is called strain. And deformation can be change in length, change in area, change in volume. Right? So you can say that this strain is equal to change in length, means delta L, by original length L. Okay? So at one particular instant of time, suppose the original length of the body is L, but after applying some load, this L has changed as L1 at time T1. Or we can say that the original length was this one. Okay, no problem. So L1 at time T1 and another time L2 at time T2. Right? Suppose the body at some time T1, it is having its length as L1. At time some T2, it is having length at T2. So changing length has taken place. Okay. So that what it will be, so we can write it as L2 minus L1 by its original length L. Deformation will be what? Deformation will be this change in length. So this change in length is what? L2 minus L1. Correct? L may be the original one. You can, sorry, L1 may be the original one. L2, more length has come. Right? So divided by L. So this L2 minus L1 we have written as delta L by L. Right? So strain is not having unit, I am sorry, for the unit of stress, SI unit of stress is Newton per meter square. Force by area? Force by area. So Newton per meter square. Please note it down. Okay. Now, for stress, what will be the dimensional formula? So stress is equal to force by area, and force was having M L T minus 2. Okay, area is length. So length is square. So it will be again length minus 2. So this dimension formula will be for what? So M and L minus 1, T minus 2. So it will be its dimensional formula. So SI unit of stress is Newton per meter square. But when we are talking about SI unit of strain, so it is also length only, it is also length only. So it is the ratio of length only. So there is no unit. There is no unit of strain. Okay? So you can write it as strain. This one you have noted down already? And strain is ratio of one property, as strain is the ratio of a single property, that is length, hence it is not having any unit, not having any unit. Okay, so this is called strain. Later on we will be talking about volumetric strain and other things. Okay, we will discuss the Hooke's law first, right? Okay, so what is Hooke's law now? Whether you have noted down this one? Okay. We will be discussing now Hooke's law of elasticity. Very important. Hooke's law of elasticity. Or better, I will be writing there. Note it down. You understood now this one? So its deformation per unit length is called strain. It can be of change in length, change in area and change in volume. So strain is the ratio of delta L by L. So that's why L is the ratio of single property, that is length only. So it is not having any type of unit. Okay? Note it down? Very good.
The second one.
Oh. So further, a very important concept, that is Hooke's law. We are going to discuss about Hooke's law now. Okay? So what Hooke's law says, so you can say that Hooke, actually Robert Hooke was the scientist, okay, who explained the mechanical behavior of materials, right? So Hooke was the metallurgist or scientist who explained the mechanical behavior of materials, especially relation between stress and strain, especially between stress and strain. What is the relation? Right? So, as per Hooke's law, stress is proportional. Yes, stress is proportional to strain. Okay, up till when? Up till elastic limit. If the material is loaded within its elastic limit. Okay, so as per Hooke's law, stress is proportional to strain within strain. Okay, if the material is, or you can say, if the load is applied on the material, if the load is applied on the body within its elastic limit. Okay? So within its elastic limit. So it says that within elastic limit, stress is directly proportional to strain. Stress is directly proportional to strain. Then further, stress is equal to, we can say that proportionality constant Y. Proportionality constant Y. And Y is what? Young's modulus of elasticity. Y into strain. Where Y is Young's, you will be writing as proportionality constant. Proportionality constant and called as Young's modulus of elasticity. Okay? Young's modulus of elasticity. So stress by strain. So from here, Y is equal to stress by strain. Now what will be the unit of Young's modulus? So this is called Young's modulus. So the unit of Young's modulus, what is the unit of stress?
No unit, sir.
What is the unit of stress? Newton per meter square. Newton per meter square. What is the unit of strain? No unit. No unit, man. No unit. Deformation per unit length. So as I told now that it is the ratio of single property length only. So it is not having any unit. So it is not having any unit. Strain is not having any unit. But stress is having unit. So Young's modulus unit also will be stress unit only. So unit SI, unit of Young's modulus is Newton per meter square only. Correct? Right? So generally what it is there, Young's modulus or even E is written. At many places this Young's modulus Y is not written, it is written as E. E is showing that its elasticity, modulus of elasticity. So generally stress is equal to E into strain. It is written in this way. Okay. So where or E is equal to stress by strain, where E is what? Modulus of elasticity. SI unit is Newton per meter square. Understood? For each and every material, a specific modulus of elasticity is there. Okay, so when you are solving some questions in the examination, you will be given value. Suppose for steel, modulus of elasticity will be different. For aluminium, modulus of elasticity will be different. For wood, modulus of elasticity will be different. So that value will be given to you in the examination. Right? Okay. So just please note it down. So this is a very important phenomena, or you can say the law applicable for mechanical properties, that is Hooke's law. So as for this one, if the load is applied within the elastic limit of the body, then stress will be directly proportional to strain. What does it mean? It means that within the elastic limit, if the body is applied load, then problem will not be there. Then there will not be any problem.